is Kwame Darko-Mensah, and my teammate is Krisa, and today we are World Cup data analysts. So in our project today, we have studied the relationship among statistics within the sport of soccer. To give a brief background about soccer, soccer is a sport that is played globally, and outside of the United States, it's known as association of football. It's a sport that is played generally between two teams that have 11 players on the field at a time. The performance of a soccer team is usually a combination of factors, which could be the player's ability, the formation of the team, or the opponent, the quality of the opponent that the team is playing. Teams spend considerable amount of money to acquire players, and so we believe statistics is important as it helps managers to scout for players on the open market. So soccer would be played at club level or international level, and based on our data set, which was taken based on the FIFA World Cup tournament, which is an international soccer event that is played every 4 years. The use of modern technology today has made it able to collect large amounts of data, and these data is used by managers and team owners to create match strategies, formations against other teams. So the pre-approved data set we used was the 538, which had various aspects of player performances, which is passes, touches, goals scored, and others. The data set we used was from the tournaments for the past 14 seasons, so from 1966 to 2018, which gave us 5,900 observations. And we were able to convert most of these player-specific observations into z-scores. The z-score is calculated by taking away the mean from the individual observation and dividing that by the standard deviation. And that generally tells us how far from the mean a data point is.
Okay. In this project, we're trying to explain the goals scored, so how many goals a player scores. And so our dependent variable is goals. The rest of our variables, or our independent variables, are listed here. So we have a total, I believe, 15 variables that we're going to use to try and explain goals scored to help managers, to help players better understand how they can increase goals so that they can hopefully win more games. The definition of each of our regressors is found in that middle column. So for example, XG, that is just the number of scoring chances the player gets. So how many scoring chances did they get? The expected sign of that coefficient, that right-hand column, we believe that a regression is one of the best ways we can analyze this data. And so for this, we wanted to have predicted coefficient signs so that when we actually run a model, we can compare it to our expectations. And that's one way we can evaluate whether or not it's a good fit. If we have a lot of variables that have opposite signs, then we probably don't have a very good model. So just to draw your attention to that next variable, box touches. So this is just the number of touches taken by a player inside that 18-yard box. And we expect it to have a positive coefficient. So we expect it to be positively related to the number of goals scored by a player. This would make sense because as a player has more touches in the box, they probably will have more opportunities to score, so they're going to have more goals. A few other variables I want to take a minute to discuss are take-ons, which is the number of times a player takes on or gets past a defender on the other team. Blocks, which is the number of times a player blocks a shot. Aerials, the number of times a player challenges for the ball in the air. And progressive runs, or prog runs, which is just the number of progressive runs made by the player. Lastly, I want to point out fouls, which is just the number of times a foul is committed by the player. So next we ran a correlation table because one, we wanted to determine which variables were correlated to the number of goals scored, because we're trying to explain that variable. So we need other variables that theoretically and statistically have a strong relationship with it. Next, we also wanted to make sure that no two independent variables had too strong of a correlation. So with a correlation, if there is too strong a relationship, there can be multicollinearity between the variables, which ultimately would mean we would not have a good model. And so if there is multicollinearity, one variable can be explained from another variable, which is a problem in a regression model. So from the results, we chose 0.75 as kind of our cutoff point. Anything over that we think would be too strong of a correlation, so there could be multicollinearity. So in our example, in our table, you can see that the non-shot scoring chances, so that very last variable, NSXG, that variable is strongly correlated with crosses. Therefore, in our model, we should never have those two variables both in there at the same time. Second, we see that prog passes and passes have a strong correlation as well. This should be expected because passes is just the number of passes a player makes. So if the number of prog passes increases, the number of passes is going to increase. So these two variables should not be included in the same model. All other variables seemed usable, did not seem too high. And so second, we look at the correlation with goals. From that, I see that scoring chances has a very strong correlation with goals, which is a good sign, something we would expect. Also box touches. And this is also reasonable. As a player has more touches in the box, they probably have more scoring chances, which probably means they're scoring more goals. So I'd like to see that. Second, I see that take-ons has kind of a good correlation with goals and maybe even fouled and non-shot scoring chances. So those are just some variables that we may start with as we move on to our model building phase. So in this project, we ran a multiple linear regression model. So our population equation can be found at that second bullet point. After running many regression models, we found this to be one of the better models. And basically our goals are being explained by XG, or scoring chances, box touches, progressive runs, the number of take-ons, blocks, aerials, and fouls. And then our sample equation, as you can see, is just our expected goals with the coefficients. So I want to take us to our table next, just so we can really look at each of the regressors. The coefficient, or sorry, the intercept was taken out because all of our variables were converted to z-scores, our intercept was basically 0. And so we did not include it in our sample regression. The regressor is found on the left-hand side. The middle column represents the coefficient, and the right-hand column is the p-value. And we use the p-value to measure significance. So this null hypothesis is that this coefficient is equal to 0. And so when we have a p-value that is less than 0.1, or with 90% confidence, so less than 0.1, we can conclude it's statistically significant. So we reject the null that the beta is equal to 0, which means the variable can explain goals. So ultimately from this, a few things stand out. First, all of our predictions were correct, except for 2 blocks we predicted to be negative, but it was actually, as you can see, it's positive. And what we thought where the real story could be is that most players that are blocking shots might actually be forwards coming back to defend, blocking long range shots. So maybe there's just a story we weren't anticipating at the beginning. The second one that was wrong was progressive runs. So originally we thought it would be positive because if people are making, or players are making progressive runs, then they're going to be scoring more goals. But what we actually found is that it's negative. And we think the real story behind it is that a player making a progressive run is a player, that might be a defender or a midfielder, moving into a position higher on the pitch. Whereas forwards, which are the players who tend to score most of the goals, where forwards typically are already higher on the pitch. So they don't make as many progressive runs because they're already there. So that could be the storyline there. But everything else matched our expectations. And a few things is that scoring chances, box touches, take-ons, blocks were all positive coefficients, so all directly related to the goals scored, and all the others were negatively related. And so with this, I also noticed that our scoring chances has one of the greatest impacts on the number of goals scored, which makes sense. You get more scoring chances, you probably score more goals. But some of the others, like box touches, was one of the second largest impact regressors. And that also was something we expected, was that box touches and scoring chances are going to play a massive role in goal score. Like we just said earlier, the more box touches somebody has, the more scoring chances they're going to have, the more goals they're most likely going to have. So it was nice to see those ideas confirmed and to see it play out in our regression model. This is the interpretation of the results. So if we want to look at that first interpretation of scoring chances, so how we would interpret it is just saying that holding everything else constant, if XG were to increase by 1, then goals would increase by 0.6718 on average. Ultimately, what this means is that increasing the number of expected goals by 1 z-score will increase the z-score of goals by 0.6718. So that is the interpretation of each of our regressors in our final model. And ultimately, again, we think this is very useful information for managers as they want to increase the number of goals scored, because typically the team that scores more goals wins. Well, always the team that scores more goals wins. Therefore, knowing this information and knowing, that we really have to focus on getting our players more touches in the box, getting our players more scoring chances, maybe even telling our players to take on more of the defensive players, because take-ons had a positive coefficient. So some of these things could really be important for managers to know. Also with fouls, typically the team that is losing is more frustrated, and so they foul more. So maybe going forward, managers can say, hey, no matter what, we don't foul, because that's an indication that we're probably going to be scoring less goals. So just some examples of how these results can be helpful to managers. And yes, so thank you for listening. And have a good day.